So in the last video we saw the peptide hormones. Now we'll see the steroid hormones. See, the steroid hormones are of three types, three groups basically. How they are classified? They are classified based on the carbon atoms that they contain. Okay. So we have 21 carbon series and then 19 carbon, 18 carbon. So under this 21 carbon series we have progestogens, glucocorticoids, mineralocorticoids. Okay, under this 19 carbons we have androgens, 18 carbons are your estrogens. So we will now see the sex steroid hormone synthesis, that is known as steroidogenesis. See, this sex steroids, they are basically produced by your gonads, adrenal gland and placenta, and the primary building block for this hormone production is your cholesterol. This cholesterol can be produced using acetate, which is your 2 carbon containing compound. Okay, so most of these tissues synthesize their own cholesterol. Okay, except your placenta doesn't have the capacity to synthesize your cholesterol. All other steroid producing tissues are capable of synthesizing the cholesterol. Okay, so this steroid hormone synthesis involves at least 7 enzymes, and this synthesis occurs mainly in the mitochondria of the cell. Okay, so and they use mostly your cytochrome P450 enzymes. So they have various reactions. So in short, I'm going to teach you the process of sex steroid synthesis. I told you the building block is your cholesterol. This cholesterol is going to get converted to pregnenolone. This pregnenolone gets converted to progesterone. This progesterone is going to form deoxycorticosterone, and this will form corticosterone, and lastly aldosterone. I will tell you the enzymes involved in the synthesis. I'll just draw the outline what all products are formed. So this pregnenolone gets converted into 17 hydroxy pregnenolone. Okay, and this progesterone gets converted to 17 hydroxy progesterone. Now this 17 hydroxy progesterone will form 11 deoxycortisol, that will form cortisol. Okay, this 17 hydroxy pregnenolone and progesterone, again they get converted to, this is DHEA, which gets converted to androstenedione. Androstenedione gets converted to estrone. DHEA gets converted to again androstenediol, that forms your testosterone, and that will give you E2. This is E1, this is E2, estradiol. So now we will see the enzymes involved, because these enzymes are very much important when you are studying this development of sexual disorder. Okay, so we'll start with the enzymes. Okay, so the enzyme involved in conversion of this this step is your 3 beta hydroxysteroid dehydrogenase. All this, whatever the steps are there in the second, this all involves 3 beta hydroxysteroid dehydrogenase, and these involve your 17 alpha hydroxylase both. And next here same enzyme is involved, 1720 lyase. Okay, I forgot to write here. And here the enzyme involved is 17 beta hydroxysteroid dehydrogenase. All these steps. This also. Okay, you just have to know certain enzymes and where the enzymes are involved. And now the important, I'm just going to highlight it, 17 beta hydroxy steroid dehydrogenase here, and next 17 hydroxylase here, and the other one 1720 lyase is here. Next 17 beta hydro, wait, I'm so sorry, let me just highlight with the other light color. 17 beta hydroxysteroid dehydrogenase in this step. Now the other important things, this whole thing is by 21 hydroxylase. I'm going to highlight it, 21 hydroxylase, and last one is your 11 beta hydroxylase. Just try to remember these enzymes because it's very necessary when we discuss developmental sexual disorders. Okay, this is in brief. So I have shown you the pathway. See, these enzymes, whatever I have shown you, all the enzymes, they are not present in all tissues. So depending upon their availability in the tissue, the hormones are produced accordingly. Example, if I tell you in ovary has all the enzymes? No, they are deficient in 21 hydroxylase and 11 beta hydroxylase. So where are these enzymes? These enzymes are 21 hydroxylase, 11 beta hydroxylase. So because of this, they cannot produce hormones down to this progesterone. So they cannot produce aldosterone and corticosteroids. Okay. So like that only, not all tissues contain all enzymes. There are specific enzymes in specific tissue and thus helping in producing specific hormones. Okay, now I've told you here. I forgot to mention you the hormones here, which is important. So this here aromatase is involved in this. I'm so sorry. So this aromatase helps in production of estrone and estradiol. So this estrogen is of 3 types now. estrone, estradiol, estriol. So whatever the enzyme estrone and estradiol, they are produced by your androgens with the help of the enzyme aromatase. Okay, this aromatase is present in your adipose tissues, skin and brain along with your ovaries. So that is why in the periphery these androgens are converted to estrogen with the help of your aromatase enzyme. Okay, so that's why even in a postmenopausal female we can find certain amount of estrogen, that is because of your peripheral conversion. So I already told you there are three types, E1, E2 and E3. So E1 is mostly seen in your postmenopausal female. See, remember one for single. In postmenopause, women will mostly be single. She doesn't have any help. Remember like that. Okay. Estradiol. This is mostly produced from your ovary, and that too during your reproductive years. Reproductive years means you are with your husband. So remember too. And E3 is during your pregnancy. So E3, there are three people, you, your husband and the baby. So like that you can remember. Okay, so these are the types of estrogen that is present in a body. So now this is about estrogen. Now androgen. Androgen, I've told you how it is produced. Androgen, so this 17 hydroxypregnenolone gets converted to DHEA. This dihydroxyepiandrosterone gets converted to androstenedione, and that forms your testosterone. See, this testosterone with the help of 5-alpha reductase gets converted to dihydrotestosterone. This is important for the external male genital production, and also they help in conversion of villus hair to terminal hair. That is why whenever there is hirsutism, we treat them with the 5-alpha reductase inhibitors. Understood? So that is because it decreases the production of dihydrotestosterone and decreases the conversion of the villus hair to terminal hair. Again, this hormone is of two types, type 1 and type 2. This type 2 is mainly in your male genitalia. Type 1 is expressed in your skin, brain, liver and kidneys. Okay, so we are talking about the androgens in male. Now where does this androgen comes in female? Why are we discussing in this gynecology about androgens? Because ovaries also produce your androgen. So let's see from where these androgens are produced in females. So we'll just discuss. This ovary produces 25% of your testosterone, and it produces androstenedione as well, DHEA and DHEAS. So 25% of testosterone is from ovary, and adrenal glands also produce testosterone, which is 25%. So 25 is 50%. So where is the other 50% of the testosterone? That other 50% is produced by conversion of this androstenedione to testosterone that acts peripherally. Okay, Now ovary also produces 50% of androstenedione, 10% of DHEA, but it doesn't produce DHEAS because it doesn't have an enzyme to produce that. So here androstenedione is produced by adrenal glands as well in 50%, and DHEA here 10%, so remaining will be adrenal gland. DHEAS, most of it is produced by your adrenal glands only. Okay, so this is about the androgens in female. So these adrenal glands, they have certain specific enzymes. We all know adrenal glands have 3 layers: zona, glomerulosa, zona fasciculata, zona reticularis. Zona glomerulosa, it lacks 17 alpha hydroxylase. So where does this enzyme present? 17 alpha hydroxylase. So 17 alpha hydroxylase is here. So there is no production of corticosterol. Understood? So this produces only mineralocorticoids, no glucocorticoids. This zona fasciculata and zona reticularis, both of them have 17 alpha hydroxylase, and thus they produce glucocorticoids, androgens. Okay, now so steroid hormones are produced. So after the production, how they are carried? So mainly they are transported in circulation using your carrier proteins. So most of them bind to these carrier proteins and are circulated throughout the body. So these proteins are known as sex hormone binding globulins, thyroid binding globulins, or corticosteroid binding globulins, and also your albumin. So whenever there is variation of these globulins or proteins, there is variation in the circulating steroid levels. Okay, so that is why the small changes in your sex hormone binding globulins or proteins lead to various changes in the circulating steroid hormones and their effects. Okay, so for example, I'll tell you sex hormone binding globulin. This is mostly synthesized in the liver. Also, it can be seen in brain, placenta, endometrium, and testis. So this sex hormone binding globulin is increased in your hyperthyroidism, pregnancy, and on estrogen administration. So when this sex hormone binding globulin increase, they are going to bind to the sex steroids, and thus they decrease the circulating hormones. So why I'm talking about this is because sometimes this sex hormone binding globulins or albumin, all of them bind to this androgen and estrogen, and in certain conditions we ask for the free testosterone level. Example, in your PCOS, say PCOS, you need not get the levels of the testosterone in the body, but if you are asking, sometimes the lab may not measure the testosterone level properly and you may get abnormal values. So while interpreting, you should be very careful and vigilant, and you should know why it has increased and all. Okay, so this is about your sex steroids.